Yeah, so the last time we talked about complex numbers, how you can represent them in different ways. In the complex plane, we have the real part and the imaginary part. And we can describe this as a vector that is a combination of the two. So A plus JB, for instance. But we can also look at the vector like length of the vector and a phase, which we can also represent in a very compact and convenient form, where we have the amplitude and an exponential phase. And which one you want to use differs a little bit depending on the thing, but multiplication becomes much easier in this form, for instance. So if we have two amplitudes, or two vectors of different amplitude and different phase, and we multiply them, the result is simply the amplitudes multiplied and the phases added. Like that. That's simple enough, right? Now, we're talking about multiplication. We haven't looked at what it actually looks like as a waveform. So I'll try to draw. We start with, for simplicity, we have an amplitude of 1. So, if we were to have a sine t plus sine t, like that. We said that adding the two together is not difficult. When there's the maximum becomes larger like that. And the same for the negative side. So adding two sinusoids results in something like that. What about multiplying? Well, multiplying does not mean that you have a larger amplitude. Furthermore, the negative times itself becomes positive. So the resulting multiplication of this one is very similar, but not exact in shape, to the original sinusoid. But it's also only positive. So by multiplying a signal with itself, it becomes a positive, all positive function. You also notice that anything multiplied with 0, of course, is 0. So if we were to have another signal added, where the frequency was double that of the original. At every time we have a 0 crossing, we know that there will be a 0. If this amplitude is still 1, like that, this one is multiplied by less than 1. So the resulting amplitude is not quite as high. Here we also have negative. That means the resulting wave must be negative. Again, multiplied by less than it. So even if they both had equal amplitude, the resulting amplitude here would be less, actually, because we multiply with something that is less than 1. So here goes down, here goes down again, here goes up, because they're both negative. So here we have something similar to that. So this means that multiplying two signals generates something different in